turn to page 60 in your workbook and locate the key concept page for section 1-9. In section 1-9, dividing rational numbers, we will apply the rules for dividing integers to dividing other rational numbers such as fractions and decimals. The key concept at the top reviews the two rules we will use in this lesson. First rule, if the signs of the dividend and divisor are the same, then the quotient is positive. So a negative divided by a negative is a positive quotient. Number two, if the signs of the dividend and divisor are different, the quotient is negative. So when you're multiplying or dividing opposite signs, your quotient is negative. These are the same rules we were following when multiplying and dividing integers. Let's move on to the essential question. How is dividing rational numbers like dividing integers? The key concept went over this. What I'm going to have you do is write down these sentences, and where you see the lines here where the words are missing, you will fill in the words positive or negative. The same rules are going to apply whether you are dividing rational numbers or integers. If the numbers being divided have different signs, the quotient is positive. I'm sorry, if the signs are different, the quotient is negative. If the numbers being divided have the same sign, the quotient would be positive. Number two, how do you know the signs of the quotient negative 4/5 divided by positive 1/6? So you're going to copy that down, including the lines, and then you're going to fill in the missing words. So the missing words would be either positive or negative. So the quotient in this example would be negative because a negative rational number divided by a positive rational number is a negative rational number. So again, when you are multiplying or dividing opposite signed numbers, the product or quotient will be negative. Moving on to question number 3. When -4 is divided by a rational number between 0 and 1, where would the quotient be located on the number line and why? So I think it is helpful with a question like this to come up with an example that meets the criteria given. So I am going to give you a statement here. It's got a missing word. It also has a line here, and you will circle the word either left or right to make this statement true. And the example that I came up with was the -4, which is given, and we're dividing it by some number between 0 and 1. So on a number line between 0 and 1, it would be a positive, and 1/3 would fall somewhere in between those numbers. So I picked a positive 1/3. So you can use this example to help you fill in the missing word and to circle the correct answer. Okay, take a minute or so, think about that, fill it in, and we'll discuss in a moment. So the quotient is going to be negative because we are dividing a negative and a positive. So opposite signed numbers, the quotient will be negative. Now the question here in the next statement is whether or not the quotient that we get will be to the left or the right of the -4. So we can go ahead and kind of work out this problem. So when you divide with a fraction, both numbers need to be simple fractions, either improper or proper fractions. So we want to put our whole number over 1, and then we want to change the division problem to the multiplicative inverse. Now that is a really important word. We're going to define it in just a minute in another space where we have a little bit more room. So to do the multiplicative inverse, we are going to keep, change, flip. So we're going to use the letters KCF at the top just to help keep our steps straight. So if we keep the -4/1, we're going to change division to multiplication. And we're going to flip the order of this fraction. We're going to use the reciprocal. So that would be 3/1. Next, since we have multiplication and it looks like a railroad crossing symbol, okay, if you picture stopping at a railroad crossing sign, right, you'd have that X there on the sign. Once you have that, you can check to see if you can cross simplify. So we would look on the diagonals. We have a 1 and a 3 on this diagonal, and they cannot be simplified by dividing a common factor out. And on this diagonal, we also cannot simplify those two numbers. So in this case, we'll just go ahead and multiply across the top and the bottom at a negative 12. If you picture a number line, row over here with the negative, and then and our answer 12. The answer is which number. Okay, so what I would like you to do, since this problem here is similar to the one that we just went over, they're both in proper fraction format. They're actually both, they're proper fractions, they're simple fractions where you just have a number at the top and bottom. There's no whole numbers in the front. So you can check to see if you can cross simplify, multiply across, watch your signs. So go ahead and take a minute and try number 4A on your own. Okay. When dividing with fractions, you need to turn this into a multiplication problem. This is similar to what we did with our subtraction problems. We needed to turn our subtraction problems into addition problems using the additive inverse. And if you remember, we did the keep, change with subtraction. For the multiplicative inverse, and we're going to write this down because that is a key term and I'm not seeing it written on this sheet. We are going to keep, we're going to change, and we're going to make a second change, just like we did with the additive inverse, but our second change here would be a flip, because we're going to take the reciprocal of the second number. We're going to place, as we solve this, we're going to place the K for keep, the C for change, and the F for flip above the 3 parts of our problem. Okay, so the K is above the -7/12. We're going to leave that alone. We're going to keep it. We are going to change that division sign, because it has a C above it, to multiplication. And then we're going to flip, which means to write the reciprocal of 1/7, and that will become 7/1. Now, since we have our multiplication symbol, which is like a railroad crossing sign, right? We are going to cross simplify if possible. 12 and 7 do not have a common factor. 7 and 1 also do not have a common factor, so we cannot simplify at this time. So we're just going to go ahead and multiply across the top and the bottom. We get -49 over 12. We will want to change that to a mixed number to simplify. And if that doom cloud is helpful for you, I encourage you to draw it quick. That reminds us that we've got to get the 49 under cover, right? Because it's getting wet by the storm cloud. which means the 12 would go on the outside. Okay, now 12 goes into 49 4 times. We're going to subtract 48 from 49. We get a remainder of 1. Now, since I'm working with fractions, I'm not going to turn this into a decimal. I'm going to leave it as like a mixed number because it has a fraction in it. And now we're going to go ahead and starting at the top and working our way around clockwise, we're going to write our mixed number. So 12 went into 49 4 whole times, so 4 is our whole number. And it had a remainder of 1, so that's our numerator, and it was out of 12. So that would be our denominator. And before we circle our answer, we just want to make sure we have the right sign. In the original problem, we're dividing opposite signed rational numbers, so that would make this a negative quotient. For letter B, we're given a decimal and a fraction, and using just paper and pencil, you can't do this problem, okay? Not in the current forms of those numbers. If you had a calculator, you would be able to, but you are required on this paper to show all of your work. So no calculators other than just checking your answers, okay? Now, 5/8 is not a number that I can easily convert to a decimal, okay? It is a terminating decimal, but it's maybe not one that you know by heart. In fact, I would say very, very few 7th graders would be able to do that in their head. However, the decimal here, this negative 0.05, is easy to turn into a fraction. All you do is identify the last digit place value of your decimal. So the last digit is the 5, and then you just name the place value, and that's in the hundredths place. So the fraction equivalent would be negative 5 over 100. And you know, we're going to be working with a big number here, this 100. If you can simplify this, you would want to go ahead and simplify. So I can divide the top and the bottom by 5 to make this a negative 1 over 20. Okay, so I want to use negative 1 over 20 instead of the negative 0.05. Okay, so I'm going to now rewrite my division problem as negative 1 over 20 divided by negative 5 over 8. If you want to organize your space, maybe just kind of, you know, draw a line there in between your problems. That might be helpful. And now we want to go from a division problem to a multiplication problem using the multiplicative inverse. So we have to keep, change, flip. We're going to keep that negative 1 over 20. We're going to change division to multiplication. And we're going to flip or write the reciprocal of that negative 5/8. So that would be negative 8/5. Let me make this a little more clear. That's a negative in front of that 1 over 20. Okay, so the next step, now that you have that railroad crossing symbol or that multiplication symbol, you want to cross simplify if you can. Now, I can cancel out that 20 and the 8 and reduce both numbers by dividing them both by a 4. And 8 divided by 4 is 2. So I'm going to replace it with a 2. And 20 divided by 4 is 5. And the only problem with some of these worksheets, they don't give you a whole lot of room to write. So this would equal, And now we would just multiply across the top. 1 times 2 is 2. Multiply across the bottom. 5 times 5 is 25. I'm going to look back to my original problem, and it was a negative divided by a negative, so my quotient will be positive. I'm going to just kind of section this off so it's a little bit more neatly. Okay, ask the one question. Don't forget the tip. Letter C, that to an information. Letter D, number, and we simple fraction. We're going to want over 1. Changes by letter and D give you a few. If you need a few more moments, please pause the video, continue to work on questions C and D, and when you're ready to go over the answer, you can unpause. Okay, for this first problem, we want to convert the mixed number to an improper fraction using this circle method we've been discussing in class. Remember that you're going to follow the order or the direction of this arrow. It starts with the 4, works its way around to the 6, and then up to the 1. 4 times 6 is 24, plus 1 is 25. And since we're working in fourths, we want our improper fraction to be in fourths as well. We're going to bring down the division symbol. This number is in the correct format, so we're going to go ahead and bring that down. And now we have to change our division problem to a multiplication problem using the multiplicative inverse. So we're going to keep change flip. You should have got 25 fourths times negative 16 fifths. Next, we're going to check to see if we can cross simplify. Okay, so the 4 and the 16, we can absolutely simplify those by dividing out a 4 from both numbers. 4 divided by 4 is 1. We'll replace that 4 with the 1. This 16 divided by 4 is a 4. We'll replace the 16 with that 4. On the other diagonal, the 25 and the 5, I see that they both have a common factor of 5. I can divide both numbers by that 5. So I would get a 5 here, and I would get a 1 instead of this 5 there. Once you cross simplify, it just saves you work at the end. You're going to go ahead, and plus now we're not multiplying two big numbers, 25 times 16. We only have to multiply 5 and the 4. That gives 20 over 1, which just simplifies to 20. But just double check your original problem. And since we are dividing opposite signed numbers, our quotient will be a negative 20. Okay, for the last one, we put our whole number over 1, bring down the division symbol, and the simple fraction, the proper fraction here, we can just bring it down. We're going to change this to a multiplication problem by using the keep, change, flip slogan. So negative 1 over 1 times negative 13 over 10. We cannot cross simplify, so we're just going to multiply across. And a negative times a negative is a positive, so we're going to get 13/10, which is 1 3/10 as a mixed number, and it is positive. Okay, the next section is working with complex fractions. So, you know, it is how it sounds. These are fractions that look very complicated, okay? So you have this main fraction bar here, and in the numerator spot and in the denominator spot, we have fractions or mixed numbers. Okay, now this is just simply a division problem. You're dividing your numerator by your denominator. The very first thing you want to do is unstack this fraction. So the fraction is written and read from top to bottom, kind of like that. So it's negative 2/7 divided by 1 3/4. And what we want to do is just change this to a horizontally written division problem. So since you read a book from top to bottom of the page, but you also read from left to right, that's the order that we want to go in. So the top numbers first, and from left to right, it would also be first. So this would be negative 2/7. The fraction bar turns into the division symbol. And then we have this 1 1/3 second. Next step would be to use the circle method and to convert any of those mixed numbers to improper fractions. So we have the negative 2/7 divided by, and then we have 3 over to the 1. 3 times 1 is 3, and now we're going to add the number on the top to get 4. So we're dividing by 4/3. We need to do the keep, change, flip. Now that we're in multiplication, we're going to check to see if we can cross simplify, which we can here. The 2 and the 4 are both divisible by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. Again, we're out of room in this space, but now you just would multiply across the top and the bottom since we can't cross simplify that 7 and 3. So 1 times 3 is 3. 7 times 2 is 14. And we just want to go back and check our signs in the original problem. So this was a a negative divided by a positive, so the quotient will be negative. Go ahead, take a few moments, and try letter B and C. So this will probably be the longest video that we have all year because there are so many steps to this work. All right, so for B, we're going to unstack our complex fraction. We're going to rewrite it as negative 3/5 divided by 2 1/4. Next, we'll go ahead and use that circle method to convert the 2 1/4 to an improper fraction. So I have the negative 3/5 divided by 9/4. Next, we want to change this to a division problem. So we're going to keep change flip. We're going to cross simplify. I divided the 3 and the 9 by the common factor of 3. And now I can just multiply across. So 1 times 4 is 4. 5 times 3 is 15. When I check my original signs, I see that I'm dividing opposite signed rational numbers. So my final quotient will be a negative 4/15. I can show you just kind of how to speed this up here with the last one. Rather than unstacking and then doing the circle method, you can kind of just show that circle method in the original problem. And then when I unstack and write horizontally, you can just, automatically turn that into an improper fraction. So I get negative 9/10 divided by, let's see, 5, 6, 7, 8, 8/5. And then I'm going to keep change flip. I'm going to check if I can cross simplify, and I see that 10 and 5 have a common factor that I can divide out. I can divide both of those numbers by 5. 10 divided by 5 is 2, and 5 divided by 5 is 1. I can't simplify the 9 and the 8, so now I just multiply across the top and the bottom. I get 9/16, and now I want to go back and just check what sign the quotient should be. So opposite signed numbers here divided will give me a negative quotient of -9/16. So great job with this. I know it was a lot of information. I know this is our longest video, and I know that they'll continue to be between 15 and like 20 minutes. So great job. We are now finished with the section 1-9 notes, and we will now move on to more practice. Have a great day.